Good morning, class. This is Mr. Walker here coming to you with our lesson on dilations. So, folks, this is going to be a two-parter for this because we got two different sets of notes for dilations. I'm going to let you know when we're going to end the first part and then pick up on the second part. All right. So, first off, quick review over transformations. Okay. We've gone through three of them. Now we're getting to that last one. So, a transformation is a function that maps a figure onto a new figure. Now, unlike some of our previous transformations, dilations are going to be a bit different. Okay, so let's observe some of these. We got translations, that's just us sliding our shape over. A reflection flips our shape over a certain line on the coordinate plane. And then a rotation turns the shape around and reorients it. We got about four different ones altogether. This one here is a little different. You might have noticed on some of the last ones that for the most part, the shape still stays the same kind of shape. Now, for dilations, the transformation either reduces or enlarges the original figure. So either we're going to be making the shape smaller or we're going to be going to a larger version of the shape. Now, I don't have a larger, one already kicked up here, but you get the idea. So let's get into our notes today. We're going to be at the top of our main square, and let's get to it. Dilations. So a dilation is a transformation that reduces or enlarges the original figure. This is not a rigid motion transformation like translations, reflections, and rotation. Now, we're dealing with rigid motion. Rigid just means that we're taking the shape and we're moving this around, but it still stays the same type of shape, same size of shape, same all around. With this, you're not keeping everything the same all around. It may be the same type of shape, but the size of it will going to be different. So let's get into it. We got a couple parts that go into this. And the first part is our center of dilation. So this is a fixed point about which all points in a figure are enlarged or reduced. This may be located inside, outside, or on a figure. So essentially, this center dilation is going to be where we're bringing all of our points closer to or further away from. So think of this kind of like when we were dealing with rotations, that center of rotation or that point of rotation was the origin. Or like how when we deal with reflections, there's always some line that we're reflecting over. Those things are around where that transformation is popping off. So for dilation, the center of dilation is going to be where our dilation will pop off. All right, let's get into the next part. Now, other than having a center of dilation, we also have to have a scale factor. So the scale factor is noted as K. So whenever you see some letter K, that's going to be what we know what the scale factor is. So this is the ratio of the corresponding side lengths in similar figures, and the side lengths are proportional. So this is kind of going back into what we did back with similar figures. Now, what we're going to have to do is compare different lengths of side so we can find our scale factor at times. Other times, we'll be given the scale factor, and you'll have to go through and use that to either enlarge a side or reduce a side. So we got three different types we want to focus on. If K is greater than 1, the dilation is an enlargement. If K is in between 0 and 1, the dilation is a reduction. And if K equals 1, the figures are going to be congruent, meaning that the size isn't going to change. Okay? So these are the three different types of things you want to look out for when it comes to the scale factor so you can know how it's going to change. So let's take a look at a couple of dilations in the middle of our paper here. So I want you to label a couple of things. First off, we got our center of dilation is back here where K is at. So all of these shapes here that we can possibly make are either getting closer to K or further away from K. Next, we got our preimage. Our preimage is always indicated by the letters that do not have apostrophes on them. Our image always has the apostrophes on there. Okay? All right. Let's look at some properties that are preserved under dilations. So properties that are preserved under dilations are angle measures. All the corresponding angles are going to stay the same. Next, we got parallelism. So any parallel lines are going to remain parallel between our sides. Collinearity, any points that are on the same line are still going to be on the same line after. So the same way how this is JK, this is going to also be J prime, K prime. So the letters that indicate our different corners or different vertexes are going to stay in the same place. Next, our orientation. The letter order remains the same. So if we got J, K, L, we got J prime, K prime, L prime. All right, finally, our distance is not going to be preserved. That means that the sides that we have on our shape are not going to be the same side. Okay? So keep that in mind as we go through. Let's take a look at our next bit of work. So we got some practice going on for us. Let me go through and make sure I know where this is going to be on your paper. I believe this first example, this is going to be on the right side of your paper. So let's take a look at it. We are dilating AB by a scale factor of 2 with the center of dilation being at point M. So when we are dealing with this, our shape's either going to get closer to M or further away from M. And then this whole line here, AB, when we dilate it, we have to pay attention to what this scale factor is. This scale factor that we got here is greater than 1, which means that this line is going to get bigger. So let's do a little bit of measurement here. All right, this is about 1 inch away from M, and we want to go through and double that side. Sorry, not double that side, double that length away from M. So instead of it being 1 inch away, it's going to be 2 inches away. So it's the first part of our dilation that changes up. Next, we got to go through and figure out how big our new line is going to be. So the original AB here is about 1.5 inches. So since we're going to be dilating this by a scale factor of 2, that means it's got to be double this size. So double this size is going to bring us to about 3 inches. And that's our dilation. No biggie, no problem. All right, we got 2 here on the bottom. I want you to go through and use our figures that we got here. And we're going to use a ruler to figure out what the scale factor is. Now, you may not have full rulers, but you have enough on those protractors that are at your desk. So I want you to measure out your shape and then tell me how much bigger our new shape is so that you can figure out what it is. Let's go through and do A. I'm going to leave B for you. All right. So first we want to measure our original shape, which is that black shape. Then we want to compare that to the new shape, which is 3 inches. And we got to make ourselves a ratio between these two. So our ratio for this is going to be 3 because we have to divide the original, not the original, the new length by our old length so we can figure out how big this is going to be. Now you're going to know that your scale factor for this is going to be bigger than 1 because the dotted line, which represents our new shape, is larger than our original one. So that way you can kind of go and figure out how you want to go through and find your scale factor. So for this is your original shape. This is your new shape. This right here is the center of our dilation. Okay? So use a ruler, compare the different lengths, and good luck. I'm going to catch y'all later.